Alright, now today we start chapter 5, Quotients of Monomials. So this chapter we're going to deal with dividing exponents, then we are going to divide rational expressions, which are basically binomials. So it'll start off pretty easy, I think, and then it'll get more and more difficult as we get to section 5, 4, and so on. Alright, today, how do we simplify quotients using the laws of exponents? So we talked about the laws of exponents back in the beginning of chapter 4. Today we're going to give you an additional law that we hadn't covered yet. So the multiplication rule for fractions. This is something that you should remember back from Algebra 1. For all real numbers and q and s not equal to 0, because you can't have a 0 in the denominator, p over q times r over s equals p r over qs. When you multiply fractions together, you are basically just multiplying the top, go across, and the bottom, go across. P r over qs equals p over q times r over s. That shouldn't be that difficult to remember. To simplify fractions, PR over QR equals P over Q. Now, this is basically taking a common factor in both PR and QR, such that R is the common factor, those divide out, so you're left with P over Q. So if you have something like 6 over 8, that's the same as 3 times 2 over 4 times 2. The 2's can cancel each other out, so you're left with 3 over 4. This is basically just simplifying fractions from something like I said, 6/8 to 3/4. So once again, the laws of exponents. The laws of exponents are something we covered at the beginning of chapter 4. Let a and b be real numbers and m be positive integers. Then, under the first law, a to the m times a to the n equals a to the m plus n. When you multiply numbers that have exponents but have the same base, here a, you add the exponents together. The second law, a times b, quantity to the mth power, is equal to a to the m times b to the m. Notice that you can only distribute the exponent if there is a product, not if it was a plus b, only if it's multiplied together. So ab to the m equals a to the m, b to the m. The third law says that if you have an exponent of an exponent, you can multiply the exponents together. So a to the m to the n is equal to a to the m times n. So this is kind of a shoot off from the second law. If you put an exponent there, you can multiply the exponents together. Today we introduce the fourth law. Now if a is not 0 and b is not 0 in the denominator, and m and n are positive integers, then the fourth law allows us to divide exponents. If m is bigger than if m is bigger than n, then a to the m divided by a to the n is equal to a to the m minus n. So when we multiplied exponents together, you added them. When we divide them, you subtract them. You subtract n from m based on this fraction. If n is greater than m, then this quantity a to the m over a to the n equals 1 over a to the n minus m. And the reason we do this is that when you have a negative exponent, you will basically convert it to 1 over that positive exponent. And we'll see some examples of this. So these are the same expression. The only difference is which is bigger. The idea is you do not want a negative number as an exponent in your final answer. If you have a negative number, you want to put it either on the bottom or the top. So if you have something like a to the negative 2, you would convert that to 1 over a squared. So let's take a look at example 1. 18x to the 5th divided by 6x squared. So you have two things going on here. We have 18 over 6 and x to the 5th over x squared. 18 over 6 you just simplify like it were a regular fraction. So 18 over 6 is 3. The x to the 5th over x squared, the last law tells us that you subtract 2 from 5. Since this one is bigger than this one, the answer is 5 minus 2. So your final answer is 3 times x cubed. So remember, when you have a coefficient, you handle the coefficients separate from the variables, and you do not want a negative exponent in your final answer. Example 2, we have negative 35p to the 4th times q over 14p to the q, p times q to the 4th. So again, you will handle everything separately and put it all together. You handle the coefficients, the numbers, you handle the p, and then you handle the q. So 35 over 14, they have a common factor of 7. So your answer is going to have a -5 and a -2. You basically divide a 7 out of the top. P to the fourth over p, since the the exponent here is bigger than the exponent on the bottom, you will have a p to the 4 minus 1. That gives us a p cubed upstairs. For the q's, we have a q to the first and a q to the fourth. Since here the denominator exponent is bigger, we take 1 over n minus m. So you're going to have a q cubed on the bottom. So your final answer is -5p cubed divided by 2q cubed. And again, you do not want a negative exponent in your final answer. So you're basically canceling out what you can cancel out and leaving positive exponents where appropriate. Here's the fifth law to the law of exponents. If you have a over b quantity to the mth power, you can do a to the m over b to the m. So when you have an exponent outside a fraction, you can take the exponent and do the exponent of the top value and the exponent of the bottom value. So a over b to the m power is equal to a to the m divided by b to the m. Let's look at example 3. 5a over b cubed quantity cubed. So the first thing you'll want to do is notice that you can take the cube of everything inside, both on top and on bottom. So if you take the cube of everything, you get 5 cubed times a cubed on the top, and on the bottom you'll have b cubed cubed, which is b to the 3 times 3 power. So with an exponent to the exponent, you're going to multiply the exponents together. So on the bottom you end up with b to the 9th. So simplify the 5 cubed and you get 125a cubed over b to the 9th power. So for some of the examples, maybe you want to try them yourself. You pretty much have enough now to do the rest of the examples. You can go ahead and try them. Number 4, simplify a to the 5th over b times 3a squared divided by 2b to the 5th. So remember, when you have a multiplication of fractions, you are going to multiply across and multiply across on the bottom. So you have 3a to the 2 plus 5. You remember, you add the exponents together, and at the bottom you have 2 times b to the 1 plus 5. You add the exponents on the bottom there too. So at this time, you just simplify what you get, 3a to the 7th over 2b to the 6th. So this is something you guys should have been able to do even before today's notes. Nothing today has changed that. So again, when you multiply exponents with the same base, you add exponents together. A quotient of monomials. A quotient of monomials having integral coefficients is simplified when the integral coefficients are relatively prime, that is, have no common factor except 1 or -1. 2, each base only appears once. And 3, there are no powers of powers, such as a to the 3 to the 4th. You would simplify this as a to the 12th. So the integral coefficients are relatively prime. Basically, you reduce the fraction to its simplest form. You don't have like 4 over 2 in the fraction. You don't have like 6 over 8. You reduce those fractions as much as you can. Each base only appears once. So each base letter, so like a, b, or c, or whatever, x, y, z, you don't have like x squared times x to the third or x squared divided by x to the third. You only have one x. And then you don't have any powers of power. So you would simplify this by taking the exponent to the exponent, or a to the 12th. Let's take a look at example 5. We have that quantity, -2m cubed times n, all to the 3rd power. And on the bottom we have 3mn squared quantity squared. So the first thing you'll want to do is apply the 3rd law and take the exponent and apply it to every term inside the parentheses. Remember, you can do that. We're not adding things together. It's just one big product. So when you do that, you have -2 cubed, m cubed cubed, and n cubed, all over 3 squared, m squared, n squared squared. So all I did was take the 3rd power and the 2nd power and apply it to every factor inside the parentheses. Now it's just a matter of simplifying. We get a -8 m to the 9th power n cubed divided by 9m squared n to the 4th. And now you're going to want to remove one of the m's and one of the n's. Remember, each base can only appear once. So you want the exponent to be positive. So you have 9 minus 2. You're going to have an m to the 7th upstairs. You're going to have the n to the 1st, or n, downstairs because the 4 is bigger than the 3. So your final answer is negative 8 m to the 7th divided by 9n. And this meets the rules. We have prime factors here, relatively prime factors. You can't reduce 8 over 9 anymore. We only have one m and we only have one n. So when you divide exponents with the same base, remember you only have one base left and you want to have a positive exponent. Example 6, 5k squared over p cubed times the quantity p squared over 10k quantity squared. So first thing you want to do is apply this exponent to this parentheses, and you get 5k squared p to the 4th times 100k squared p cubed. This becomes 100k squared. This becomes p to the 4th. After that, we just multiply the top across and the bottom across, and this is what you get. Now we reduce the fraction. To make this relatively prime, we can see that 5 is a common factor. This reduces to a 20 on the bottom. What about the k squareds? Well, they nicely cancel out. And with p to the 4th and p to the 3rd, the p to the 4th is bigger, so we keep the p on top. Your answer simplifies to p over 20. Alright, so if you have any questions on how to do this, please ask me the next day in class so that I can help you with some of these examples. Example 7. Simplify 3 times 2r squared squared over 9 times 6r to the 4th. So again, you should be able to try these on your own and check your answer by pausing and restarting the video. Alright, so you combine everything, you get 18 times 2 squared times r to the 4th. This becomes 3 times 6 is 18. 2 squared, r squared squared is r to the 4th. And the bottom we just multiply across. Now, you can see that 18 and the 9 divide into each other, so you're left with a 2 on the top. The r fourths are going to cancel out. So you get a 2 times 2 squared, which is 4. 2 times 4 is 8. That was a pretty simple answer. Just because you see a lot of letters doesn't mean there are going to be letters in the answer. Alright, example 8. Negative 2u cubed v squared quantity squared all over 12u squared v to the 4th. So this will be our last example. Again, you want to take the square root of everything on top, and you get negative 2 quantity squared u to the 6th, which is u3 squared, and v squared squared v to the 4th. Alright, so let's square the negative 2. You get 4u to the 6th v to the 4th all over 12u squared v to the 4th. The v to the 4ths are going to cancel out. The 4 over 12 becomes 1 over 3, and the u to the 6th over u squared, you're going to be left with u to the 4th on the top. So your answer becomes u to the 4th all over 3. That's it for section 5.1. If you have any questions on how to do this, please ask me in class and ask questions on School Loop or the Facebook page.